Well, good day, everyone, and welcome to our session. Today is a special session on entity relationship modeling, as requested by you guys last week. So, today's session, I'll be looking at what an entity is, what a relationship is. We look at scenarios, and you have to figure out what the entities are, what the relationships are. We'll also look at the attributes of entities. And then after that, we look at in terms of the constraints, participation constraints, whether it's one-to-one or one-to-many, that sort of thing. And then we would look at normalizing our conceptual ER diagram. So that's what we'll be covering in today's session. As usual, I usually have a word for you guys today at the start. So today, our word is the power of words. Your words have creative power. Your words can build up, it can tear down. Your words can bring victory, as well as your words can speak defeat. Your words affect your future. To be quite honest, your words not only affect your future, it can impact other people as well. You can speak life and you can speak encouragement, or you could speak strife and you could speak division. But when you speak God's word over your life, you set into motion the very things you declare. What are your words saying? What are the words producing in your life today? You can change the direction of your life by changing the words you speak. Often I hear students talk about things are always tough, things are always bad, etc. No matter what the situation is, it's always horrible, and it's not often you hear someone saying something special about themselves as well. Often we use our words to describe us, and often our description of ourselves is a defeated mentality as well. So I'm encouraging you guys today is to speak powerful words about yourself. See yourself as a victor rather than a victim. And even when you talk about others as well, talk about them and say things to them that can build them up, because often we don't know what other people are going through. And sometimes it's so important for us to say a positive word to someone in spite of what their position, whether it's high or low, etc. We're all humans. We all need words of encouragement. Sometimes it's easy to tell someone something negative, but especially when we're angry. And even when we're angry, we believe we have the power to tell people whatever it is we want to say as well. But always remember that your words can really break down and tear down people as well, including our own selves. So just be careful about what it is you choose to say. So back to today's lecture, this is what we'll be covering. So in this section, we'll look at, well, previously we'll look at relational model, etc. But today's class, we're working on the entity relationship diagram. So that's our focus in today's session. So the structure of today's session will be entities, attributes, and relationships. Then we look at additional features of the ER diagram, such as strong and weak entities, attributes of relationships as well. And then we would look briefly at enhanced ER modeling. And then finally, we will convert our conceptual ER diagram to a logical ER diagram. Now, in terms of ER modeling and the purpose of it, ER modeling really is used in the very early stages of your database design. And that is why the design part comes before you implement. So first you gather the requirements, and after you've gathered the requirements in terms of what the customers want, and often your requirements help to describe the system as well. Now that you have that information, you could use that information as input to your ER diagram. So the ER diagram is the early stages of your database design. And the purpose of your ER diagram, particularly the conceptual ER diagram, is it really is a visual representation of the database, and it's something you could use to discuss with the client. So often when you have a discussion with the client, although they don't need to know the proper ER models, etc., but the conceptual ER diagram is easier to liaise with the vendor as well, to discuss relationships to determine if they are accurately represented, etc. And that's assuming that when you're building your application, you're constantly liaising with a vendor or the client or the customer, as the case may be, right? Eventually, when you move from a conceptual ER to a logical ER, that's after you normalize, it becomes more difficult to understand and interpret your ER diagram. So that's why you would normally develop a conceptual ER first, because it's easier to talk and discuss a conceptual ER with a client who does not know about ER diagrams, right? Because it's a bit more straightforward to understand. So in terms of it, we will be given a scenario, and then we will use the diagram to represent the concepts such as the entities, etc. And we'll also look at the relationship between entities also. In terms of the general process or the design process for a database, ER diagram is what we call a conceptual model. And after from ER diagram, when we normalize, etc., we get our logical model, which is really our relational database schema. And then from there, the physical model is where you actually create your table, add indexing and all of those. So that's why we say ER diagrams are the early stages of your database design. The final stage of the design is where you actually create the tables, etc., in the implementation chapter. So in terms of the concepts now, right, ER diagram is a useful tool for discussing concepts, right, about what sort of data is to be held in the database. Now, ER diagram does not address issues such as how the data will be physically stored. So that's not part of ER diagramming. So given that's the case now, this is just an overview as well. When you draw ER diagrams, there are different notations. I'm sure many of you who have ever looked at an ER diagram, you will see that in one book, they use one method or one notation, in another book, another notation. Which one is right? Which one is wrong? They are all correct. There are many different notations or styles for drawing an ER diagram. You simply have to choose one that you choose to follow, and you need to consistently apply it in your ER diagram. Okay, so in the different textbook you use, the style or the notation used for ER diagram may vary. In this particular class, I'll be using one particular type of notation, which we will discuss and we'll look at as well, and use it consistently throughout the course as well, right? Okay, so based on that now, let's start with our first section. Our first section, we're going to look at or identify entities. So we're going to discuss what an entity is, and let's see if you could identify entities. It's going to be a lot of exercises. Then we look at attributes as well as the relationship between entities as well. So those are what we'll cover in our first session. So in terms of the ER diagram, first of all, what is an entity? All right. An entity basically is anything you could store data about. So for something to be an entity, you need to be able to store data about it. So for example, if I told you that a person, if I said is a person an entity, what makes, if it is an entity, you need to store information about a person. So for example, their name, their date of birth, their address, those are what we call attributes of a person, or that's the information you store about them. Then because they are information we could store about a person, then person is an entity. Okay, a phone number may not be an entity, because what do you store? The phone number itself is a number, but there's nothing more to store about it. So the phone number ideally would not be an entity, right? So a name itself would not be an entity. Name might just be an attribute, but the person might be an entity because you could store information about a person. Now, in an ER diagram, how do you represent an entity? Well, in an ER diagram, an entity is represented by a rectangular box, and the name of the entity goes inside of the box. The typical notation for the entity name, the entity name should be one word. If it's made up of more than one words, it needs to be joined together as one. You cannot put spaces, etc. Okay, the entity name must begin with a capital letter. So this is using the notation I am discussing here. So in this notation, the entity name begins with a capital letter, right? And the other letters are lowercase, right? So that's the notation used in this particular example. So in this notation as well, relationships can have attributes. We'll discuss those rare examples. Relationships themselves do not have primary keys. Only entities will have primary keys. And the only way in which one entity type can relate to another is via a relationship. So the only way you could relate two entities is via relationship. Okay. All right. Another thing is in terms of the use of singular and plural. In the notation I am using, we would use singular to represent entities. So therefore, you would see employee as the entity rather than employees, right? Okay. Okay, so the reality is that it's all based on your choice. So some textbooks use plurals, but the examples we have, we will typically use singular. Next, so in terms of an entity now, an entity is a real world object, something you could store data about. and it should be distinguishable from the other objects. So normally an entity is a noun. Remember what a noun is, right? The name of a person, animal, place, or thing, and it's represented by a rectangular box in the ER diagram. If the entity name is made up of more than one word, notice they all join together, as in the example here, name of entity, name with a capital N, O with a capital O, and E with a capital E, all the others lowercase, join together. So you follow the naming convention for the entity using the notation we are using here. Normally, as I said, entity is a singular noun. So for example, there are two entities in the diagram there, staff and branch. Those are the entity names. Notice in each case, the entity name is made up of a capital letter to start with, right? And they are both singular, okay? So that's the notation we are using. In rare cases, we would probably use a plural only if the singular is what we call a reserved word, okay? All right, let's look at an example now. And you have to do a lot of talking in this class, right? Because I'm going to do a lot more exercise driven. A university database contains information about professors. Professors are identified by their social security number. And it also stores information about courses. Courses are identified by a course ID. A professor would teach a course. Could you, using this example here, identify the entities in this scenario? So I want you guys, so you have to talk now. So there are 7 of us here. And if you guys don't mind, start sharing with me, what are the entities you're seeing here? Take those mic off mute and chat with me, please.
Courses.
Right, so course, right? So we'll use the singular. So courses as described here, but we'll use singular, course as an entity. Now, why is course an entity? What information are you going to store about a course that makes it an entity? Anybody could answer. It's not one person who answered, have to answer everything. You guys could.
Professor that teaches it.
Pardon?
The professor that teaches it.
All right, so is it the professor is an entity you're saying, or is it that the professor teaches it is why the course is an entity?
Okay, that's a kind of two
No problem. So not to put anyone on the spot, really. So
the professor is an entity as well.
Yeah.
Professor is an entity and course is an entity as well.
Yes.
But in order to be an entity, we need to store information about the professor and store information about the course. If you look at the case study, it tells you what you're storing about the professor. What information can you store about the professor? It's in brackets.
Social security number.
Correct. So a professor has a social security number. So that's an attribute, or that's information stored about the professor. Of course, the professor will have a name and all of that, right? But we're just fixing on the case study here. So if we limit it to what we're given here, professor is an entity and social security number is an attribute, or it's information is storing about the professor. And that's what makes professor an entity, because it's storing information about him. And about the course, what information are we storing about the course?
The ID.
The course ID, very good. So course is an entity and the course ID is an attribute. Now, this line here, professor teach course, or professors teach courses, right? Is teach an entity? Do you think teach is an entity based on the case study? Or is teach a relationship between the two entities? What do you think?
It's a relationship.
So first of all, teach is not a noun, teach is a verb, right? It's a doing word, and therefore normally entities are nouns, right? Teach is a verb. So normally, because teach is the relationship between professor and course, that's what linked the professor to a course, where the professor teaches the course, okay? So that's our first one. Okay, so the solution would be we have two entities, one for professor and one for course, right? And therefore, what I'm doing, I'll describe the entities like this as well. Now, the reason I'm describing it like this also is because remember, when you do your ER diagram, after you do your ER diagram and you normalize it, the next stage is your logical schema, right? For the logical schema, this is how you will represent it, like in a horizontal line, professor, and in bracket SSN, common name, and course will be course ID, course name, etc. Right? Dot, dot, dot means there are more attributes, right? But we're just limiting it based on those. And in terms of diagram, so we identified why teach isn't an entity, right? So in a diagram, you would have a box for professor, and you have another rectangle with course inside of it. Okay? Good. Next, determine the entities in the following case. Each online customer is identified by a customer ID and has a name, an address, and a credit card number. So let's stick on that first bullet point. Can you identify the entity, and can you determine what are the attributes of the entity? What are the information we're storing about the entity?
The customer is the entity, and the attributes would be the customer ID, the name, address, credit card number.
Excellent. Very good, Cecil. And let's look now at the book. Each book is identified by an ISBN. The ISBN, we all are familiar with the ISBN number for the book, right? And so it has an ISBN number and has a title, right? Okay, so each book is identified by an ISBN number and it also has a title. Can you identify the entity in that second bullet point and the attributes of the entity? Right, come on guys. And Shania?
ISBN.
Which one is the entity?
The ISBN.
The ISBN is the entity, or you think the book is the entity? What?
Oh, yeah. The book? Oh, yeah, the book.
The book will be the entity because on what information are we storing about the book? So for the book, the ISBN number and the title is what we're storing for the book, right? So the book is the entity and the ISBN number and title are the attributes. Good? All right. So you all okay so far though, right?
Yeah.
Good.
Yep.
So the entities are the customer and the entities are the entities are customer and book. And if you have to represent them in an ER diagram, it looks something like this: customer and book. Good. All right. Next, let's see if you can identify. It's a little bit more complex. As I say, it's more exercise driven because the practice is to help you to identify them, right? So in this one here now, a newly established 5G mobile communication company needs to develop a relational database to support their business. At this initial stage of their operation, the database must accommodate the following. So please know that first bullet point is simply to describe the scenario. It's to tell you about what they're trying to do, but without getting into the problem. So there are no entities in the first one. Now we start now. So they need to store customer details, including their name, their address, their date of birth, etc. And each customer will have a unique customer number. So take a look at that. Okay. LaQuinta, you want to try for me and tell me what you think the entity is in that first bullet, in this bullet point here, which is the storing customer details, what you think the entity might be, and what you think the attributes would be from that first bullet point.
Well, I would say the entity would be the customer details and the attributes will be the name, address, date of birth, etc.
Excellent.
Along with the customer number, well, a unique number.
Right. Now, good. Now, what we're going to do now, you see they said it has a unique customer number. Later on, when we get into primary keys, the primary key must be unique, right? So the customer number will be the primary key of the entity. So the entity is customer and the primary key of the customer. So the attributes will be customer number, name, address, date of birth, etc. Right? Very good. Next one now. A customer may sign one or more contracts with the company. Now, just like when you take out a phone, you take out a contract as well. So a customer may sign one or more contracts with the company. Each contract is for one and only one mobile phone number, and it is associated with one and only one price plan. You all familiar with plans that like Digicel or B-Mobile may have as well? They have different price plan. Are you all familiar with those terms?
Yeah.
Good.
Yeah.
So you have price plan, and when you now what is saying, a customer may sign one or more contract. The contract itself is really the phone, but it's to get a phone you need to sign a contract, right? And that contract is linked to a price plan. So when you take out a phone, it's linked to one price plan, right? So if you could identify in the second bullet, that last bullet point for me, we already know that the customer is an entity. Can you identify any other entity from the information provided there?
Contract.
The contract would be an entity, yes. And in terms of the contract, you will probably store information about the contract, such as the contract date, the phone number that's linked to the contract, etc. Right? Good. And what else? Any other entity you can suggest there? It's a discussion. It's okay to get it wrong, etc. Because I'm focusing more on our learning. So don't be afraid to ask and to talk, because I'm not here to try to embarrass anyone, and I'm not looking for only right answers. I'm looking for more discussions on it. There's
Would
one.
it be the company?
Oh?
Would it be the company?
Well, the company itself, if you have a database and there's only one company, the whole database is for the one company, you don't need a table or an entity for the company. But if there were many companies, right, then you would need a table to store the companies. But in this particular case, it's the price plan. The reason is that if you think of price plan, right, a price plan will have a name. You know, like some of them have different name for their price plan, like whether it's gold, silver, bronze price plan or that kind of thing. You know, they have price plan. So the price plan have a name. It have like information such as how much a cost for the plan as well. So the price plan has a price. It has like a description, like how much minutes you will get, etc. on it, right? So a price plan is itself an entity, because the price plan is not just the name of the plan. A price plan will have a lot of information about the price plan, such as it has a name, it has a value, it has like how much minutes you'll get, how much, you know, the different things, how much calls, or the price for the calls on it, and that kind of thing. So all of that is information about the price plan. So the price plan is also an entity. Okay. Are you all following in terms of why the price plan is an entity?
Yes.
Good. All right. Am I going too slow, or is the pace okay with you guys so far?
Okay.
It's good.
All right, cool. Okay, so next now we're going to look at attributes of entity. Now, even while we were doing the earlier discussion, you guys were already identifying the attributes of the entities. The attributes really is the information that you're storing about the entity, right? So the attributes of an entity is simply a property or description of the entity, or is the information you're storing about the entity. So for example, an employee, the attributes of an employee may be the employee number, the name of the employee, the day the employee started working, right? Now, please note, if you could link this back to the actual tables, the entity actually is the table that you're going to create. And the attributes of the attributes here are the attributes of the table. Those are the fields you're actually going to store in the table. So I want to ensure that you understand the link between entities and the actual tables later on. So the entities will be the tables that you create, and the attributes here are the actual fields that are part of the table, right? So we have the attributes there. So in UML, the name of the attribute, so we are using a UML format to do our ER diagram. The name of the attribute is displayed with the first letter in lowercase. So note the entity, the first letter is uppercase, but in the attributes, the first letter of the attribute is lowercase, right? However, if the name of the attribute is more than one word, then the first letter of each subsequent word is uppercase, like telephone number, TELNO, the N is capital because there's more than one word joined together, right? There are no spaces in the attribute names. All right. So using this example here, right? Could you identify, question?
Yeah, just to interject. So is it mandatory, if you go back to the previous slide a second, so in naming of your attributes, is it mandatory that you have to use the second word as being uppercase, or you could leave it entirely lowercase?
Well, because I'm following the UML notation, this is the syntax of the UML notation, right? However, because an entity relationship diagram is simply a diagram, right? If you don't follow it at T, it's not a big issue. If your marker who is marking it is fully familiar and with the UML notation and is aware using UML notation, then he may want you to stick to the UML notation. But if he's not aware, remember your supervisors may not be jack of all trades. They may have some general knowledge on the different areas, but they may not be an expert at this level of detail, right? So if they're not, then you could get away with it. But if they are, then they probably want you to stick to that notation. Okay, assuming you're using UML.
But in proper practice, this is the way it should be
It
done.
should be in UML. If you're using, remember, there are many different notations. So if you're using UML notation, this is the way you have to do it, right?
Okay.
Not every notation requires it. So in this case here, let's identify the attributes now of the entity. So for the entity professor, what were the attributes we discussed here? The attributes of professor?
Name, security.
Security number, name, good. And for the course, what attributes of the course you could think of so far?
Course ID or course name.
Very good. Course ID, course name. And if you have to add other attributes that are not in the table, not described here, tell me some other attributes of the professor you could add on. So we said Professor SSN, Social Security number, is the primary key. What other attributes you could store for the professor other than their name?
Address.
Address, date of birth, maybe his mobile phone, etc.
Yeah.
Good. All right. And for the course, course ID, course name, the number of credits, etc. Good. All right. Good. So those are examples. Okay. Now, in terms of ER diagram, attributes are shown in an ER diagram under the entity name. So in our ER diagram, this is the following. So just to show you how the attributes are described in the ER diagram, right? So in your ER diagram, the entity name is written at the top. Then there's a dividing line. By the way, you don't need to color it. The coloring is just simply because I pulled it from a book, right? The coloring is not mandatory. So the entity name is at the top, customer, and the other entity name is book, and the attributes are listed at the bottom. Notice the attribute are lowercase. And for example, for credit card number, notice the capitalization of the other words like credit card number. Notice the card has a capital C and a capital N. ISBN and title are all lowercase as well. So these are how you represent the attributes in an entity. So the entity is at the top in a rectangle, and within the whole box, you have the attributes listed below the entities. Are we okay here with the notation for entities and attributes?
Yes.
Good, no problem then. So based on this here, if they tell us that the customer is identified by customer ID, name, address, credit card number, this is how we would represent it. So the customer has the customer ID, name, address, credit card number. Now please note, it is generally, the practice is to put the primary key first. When you're listing the attributes, put the primary key first, okay? If you have foreign keys, they don't need to be, it's not a requirement to put the foreign keys next. The main thing is the primary key is listed as the first attribute in the table, okay? When you're drawing a diagram. All right, so next, if we had to draw a diagram to represent this, we already identified the entity and the attribute. Customer is the entity. They have a name, address, date of birth, and a customer number, right? So the customer number will be the first attribute. And in terms of the contract, we said contract is an entity, and price is also an entity, okay? All right, so the next thing we're going to look at now is what we consider simple attribute and a composite attribute. A simple attribute is simply an attribute that cannot be further subdivided into smaller components, such as, for example, customer ID or gender, right? Gender, these are single value attributes, so it's a simple attribute that cannot be subdivided. But a composite attribute is an attribute that you could further subdivide into smaller attribute. For example, if I use name as an attribute, could you tell me can name be subdivided into smaller, simple attributes? If so, what are they?
Yeah, first name, last name.
Very good. So name will be considered a composite attribute, and address would also be a composite attribute because address could be further broken down into street, town, country, etc. Now, when do you subdivide or when do you leave it as composite, right? If your situation requires you to have first name and last name separate because you need to sort by name and all of those things, then you may separate name. Instead of having name as the attribute, instead you have first name and last name as the attributes. However, if you just want to store the person name and you're not concerned about separating the name into first name, last name, and things like those, then you could simply store it as name. It's easier that way. And the same thing with address as well. You could just have address as an attribute because you're not interested in finding out their street, their town, postcode, etc. You just need to store an address, so you store it as that. However, if it is that you will be running, if you're going to run reports such as, you know, you want people in a particular town, etc., then you should subdivide it into smaller attributes, right? So those are the notes on simple and composite attributes. Now, how do you represent simple and composite attributes in an ER diagram? So for simple attributes, we simply display the attribute name in a list below the entity name, which is what we did before. But for composite attributes, what we do for composite attribute is the name of the composite attribute, and then we indent now the simple component attribute, right? So for example, customer ID is a simple attribute, name, right? So let's suppose that you want to keep name as a simple name as is, because you're not interested in breaking it down into first name, last name. But for the address, you want to separate the address into street, town, and country. Then this is how you could represent it in an ER diagram. So for a composite attribute, you would use street, town, country. And notice those are under the address attribute. So street, town, country are the breakdown of the address attribute, okay? But you only need to do this in a conceptual ER diagram. In a logical ER diagram, you would remove address and simply leave street, town, and country. Another thing to note as well for you guys, this exercise is to show you how to represent composite attribute. But the truth is, if you want, you don't need to put address on this here, street, town, country. You could remove address and simply put street, town, and country as attributes if you prefer. Good? So you don't have to leave it as a composite attribute knowing that you're going to break it down. You can simply just break it down and remove address totally and just leave street, town, and country. Okay? All right. Next, we're going to look at single valued attribute and multi-valued attribute. A single valued attribute simply stores a single value. For example, the customer ID stores a single value. If, for example, name, you're only storing one name in it, then that's a simple attribute or single valued attribute. However, sometimes you may need to store multiple values for an attribute. And if the attribute is storing multiple values, it's called a multi-valued attribute. So for example, suppose each customer has up to 3 credit card numbers. They have 3 credit cards, right? So then for one customer, you need to store 3 credit cards. Then that's a multi-valued attribute. So credit card numbers are multi-valued attribute holding up to 3 values, okay? So how do you represent that in an ER diagram? So you have customer ID, name, address, and for the credit card number, you put 1.3, meaning that a customer can have between 1 and 3 credit card numbers. Now, this is only in your conceptual ER diagram. In a logical ER diagram, you cannot store one and many in the same table. So therefore, you know, we would eventually remove credit card number from that table because, you know, it's a multi-value, okay? So, but this is how you represent multi-valued attribute in a table. Okay, so in this here, what the 1.3 is saying is that you could have between 1 and 3 credit card, a max of 3 credit card per customer. Okay. All right, next, we're going to look at what we call derived attribute. A derived attribute is simply an attribute whose value could be calculated from other fields. So for example, if you look at a lease, you know, like if you're going to rent a building, you need to get a lease. So a lease has a lease ID, it has a start date, it has an end date, and it has a duration. Do you think duration can be calculated based on the values of the other fields? What are your thoughts? Duration can be calculated based on the start date. Duration is simply the difference between the start date and the end date. So duration is what you call a calculated field. So duration is a calculated field whose value now is based on the start and end date. And therefore, because it's a calculated field, it's called a derived attribute. In some cases, there are two theories on derived attributes. One theory says don't store derived attributes because you could always calculate it. And another theory that says if the database has a lot of data and therefore and the derived attribute is a value that you're frequently using in reports, then you may want to store it in the table rather than calculate it each time you need to pull it up, right? So those are the two schools of thought there regarding the use of derived attributes. Okay, so let's take a look at this now. Can you identify the derived attributes in the following scenario? So there are three entities and you have the attributes. The primary key is underlined. The primary keys are underlined and the asterisk represents foreign keys. But that's not the focus of this question. The focus of the question, however, is to look at each entity and determine if there are any derived attribute, any field that has been calculated. So I'll give you a couple of seconds to look at it and see if you can identify any derived attribute in those.
So Ravi, if you're looking at the first one, item with item number, you're trying to get two attributes inside there to give you the item number.
No, in the item table, the item number is describes or uniquely describe each item, right? So each item has a unique item number. They have a description and it has a cost. But none of those are derived attributes because none of those can be calculated using other values, right?
Oh, yeah.
You cannot calculate the description of the item. The unit cost of the item is stored in the item table. This is where you know the price of each item. So nothing there in that table is calculated. Right.
Right,
However,
and the same thing for order, because you have a date and you have the order date and the total cost, but that wouldn't give you an order number.
No, the order number is not about the primary key being derived or not. It's about any of the attribute, any of the attributes. So the order number is a unique number you're assigning to the order every time an order is created. The order date is normally the date that the order was created from, right? So that will be today's date. But the total cost of the order is really so. Like for example, if your order, you know, when you go to PriceSmart, let's suppose you bought 3 items in PriceSmart, right? You would get a bill at the end. The order line has the individual items on the bill. So let's say, for example, you buy a container of milk, a stick of butter, and a loaf of bread, or 2 loaves of bread, right? 2 loaves of bread, a stick of butter, and a container of milk. In the order, that's one order, so it will have one order number. The order date will be today, and the total cost of the order. How would you get the total cost of the order?
When you add all the items?
Right, you add the cost of the item. So in the order line now, the order line table will have the individual items in the order. So in the order line table, it will have the item for the bread, and the quantity for the bread will be 2, right? And the cost of the bread, how will you get the cost of the bread? It will be the quantity, which is 2 multiplied by the
cost of 1.
The cost. So where the unit cost of one is in the item table, right?
Yeah.
So what you're doing is the cost itself is a derived attribute, because that cost is calculated, because all you have to do, if you have the item number, you go to the item table and you get the unit cost, right? And you get the unit cost of one item and you multiply it by the quantity to get the cost, right? So cost is a derived attribute because the value of cost could be calculated using the values already stored in the database, right?
Okay.
So let's suppose that a loaf of bread is $10, a stick of butter is $10, and a container of milk is $20. A loaf of bread is 10, a stick of butter is 10, and a container of milk is 20. The person bought two loaves of bread, 1 stick of butter, and 1 container of milk. In the order line table, right, you have an entry for the loaf of bread. So the loaf of bread, the quantity will be 2 and the cost will be 20. You follow what I got that, right? Because 2 multiplied by 10 is 20. So cost is what we call a derived attribute, because you're getting cost from the other table and you're just storing it there. So cost is a derived attribute. If the other line item is the stick of butter, a stick of butter, the quantity will be 1 and the cost will be $10, because that cost is again calculated by multiplying the unit cost of the butter by the quantity. And the container milk again will be $20, because that will be, the quantity is 1 and the unit cost for the container milk, I could get that in the item table. The container milk is $20. So the cost of the milk is 20. What will be the total cost of the order then? $20 is for the bread, $20 is for the milk, and $10 is for the butter, right?
50, yeah.
$50, right? So in the order table, what will total cost be?
$50.
Did we calculate total cost based on the cost in the order line table? So in the order line table, you have the cost of each. So the bread, the butter, and the milk. And you add up those to get your total cost. So based on that now, total cost is also a derived attribute, because the total cost was calculated by summing the cost in the order line table, right? So you follow what a derived attribute is now. It's really an attribute whose value can be calculated from the other values. So based on this, what they're saying is you could choose to leave it out from the database, because whenever you need it, you could just recalculate it, right? Okay. That's one school of thought. It doesn't mean that you must remove it. It's just one school of thought says keep it if you use it a lot in reports and whenever you're processing, and another school says remove it and calculate it whenever you need it if you don't need to use it much. Okay, so those are the derived attributes. Now in an ER diagram, derived attributes usually will have a slash in front of it. You see, for example, duration, there's a slash in front of the duration in the ER diagram. Again, remember, this is UML notation, right? So this is a derived attribute and duration has a slash in front of it. All right, next. How do you identify primary keys in the ER diagram? Primary keys are identified in the ER diagram by placing PK next to the primary key. Now, so in some cases, you use curly bracket PK, and in some cases, they use curve bracket PK, right? Whichever you choose is not a big issue. What we found is that the university was using PK with the curve bracket, but the textbook was using PK with the curly bracket. So what I did was, whichever the student choose to use is fine, because both were accepted by the university. So the PK goes next to the primary key. So for example, for the professor, the social security number is the primary key. So we put PK next to the primary key. Okay? Is that all right with you guys?
Yep.
So in the ER diagram, you're not underlining the primary key, but you're putting PK next to the primary key. Okay? All right. So based on this, we know that the SSN is the primary key of the professor. Could you identify the primary key of the course table? What's the primary key of the course table?
Would it be the course ID?
Very good, no problem. So if you're drawing those or representing those in an ER diagram, you'll have professor with SSN and name, with the PK next to SSN, and the course is course ID, course name with PK next to the course ID. Good. Notice I'm representing it both ways. I'm representing both in ER diagram as well as the logical. Notice in the logical at the top, the logical schema, I have, let me just use annotation here. In the logical schema, notice you have professor and underline the SSN. This is your logical schema. So the rule is you do your ER diagram first, and from your ER diagram, you generate these here. Good? But I'm doing both with you because at the end of it, you know, I'm trying to teach both as I go along so that you understand both. You could easily convert from this to this or this back to this. You could work, you know, reverse engineer as well as work forward as well. Okay? All right, next. Can you identify the primary key in each of these entities? So all I need is if you could identify the primary key in each of these, starting with the first one, the customer. What is the primary key?
Customer ID.
Very good. And how did you determine that?
Because each customer would have a unique ID.
Right.
A lot of customers may have the same name, so you can't really use that to identify a customer.
Very good. So it also says each customer is identified by the ID. And whenever they use the term identified by, it's often an indication that that is the primary key, right? So because a customer is identified by the customer ID, that is your unique number and that is your primary key, right? Good. For the book now, can you indicate what the primary key might be for the book? Each book is identified by an ISBN number, right? So can you suggest what the primary key is for the book?
The ISBN number.
ISBN number, of course, right? And here it has, so we have two entities, the customer and the book. And here it says a customer can buy many books, right? A customer can buy many books. Now, what this is here, this is really about the relationship between the customer and the books. Normally, that relationship is a verb. The verb in this case is to buy. So a customer is linked to the book with buy. So buys is the relationship between the customer and the book. Okay? So the two entities, and you have identified the primary keys as well. So this is how you'll have them. So you have customer ID, name, address, credit card number, book is ISBN number and title. Now, please note when you're writing the logical schema like this here, you don't have to stick with the same convention here, right? Meaning that you could use capitals and stuff like that if you wish. But out of practice and getting students to be consistent, I try to maintain the same naming convention as I use here in here simply because to force a habit with students. Okay. All right. Sometimes a candidate key. So next we're going to look now at candidate keys. Now, what are candidate keys? Composite key. A composite key is where the primary key is made up of more than one attribute. So sometimes a primary key may consist of more than one attribute, and it's called a composite key. The word composite is suggesting that it's made up of more than one, right? So whenever you use the word composite, it itself telling you that the key is made up of more than one, and in this case, it's made up of more than one attribute. So when a candidate key or primary key is made up of more than one attribute, then it is known as a composite key. For example, a dose, the key for the dose table is the patient number, the drug number, and the dose date. Those three combine to form the key. So this is called a composite key because it's made up of more than one attribute. So when the primary key is more than one attribute, it's a composite key. Okay. Now, how do you label composite keys in ER diagram? You use the term PPK. PPK is partial primary key. So the PPK is partial primary key, and the only time it's partial is because you have a composite key. So each attribute is part of the primary key. So use PPK for partial primary key next to each attribute. This is what you do when you have a composite primary key. Okay. Next, alternate key. An alternate key is simply that sometimes in a table you may have more than one attribute that I uniquely identify the entity, but only one could be selected as the primary key and the others will be known as the alternate key. So the alternate key is where you have another unique value in a table. So for example, in the users table, each user may have a user ID, which is unique, and they may have an email address, which is also unique. So the email address is unique as well as the user ID, but the user ID might be the primary key. The email address will be what we call an alternate key. Okay? Okay.
So we're getting the information from the diagram from what diagram are you referring to when you're describing this?
When you do your ER diagram. So when you're doing an ER diagram, but first we need to identify what an alternate key is. So based on a case study, based on the scenario, it's possible you may have more than one item that uniquely identify the attribute. So what we're doing here simply is identifying or helping to define what an alternate key is, right? So in the ER diagram, that alternate key, you could use AK next to it for alternate key, but you don't absolutely need to illustrate it in an ER diagram. It's not necessary at all. Okay, so in your ER diagram, your choice if you want to put AK next to the alternate key, or you can leave it out completely. So in this case here, if a professor has a social security number, a name, and an email address, and your email address is unique, then you could use AK for the alternate key. Good? Now, how do you choose if the social security number and email are both unique and either of them could work as the primary key? How do you know which one to choose as your primary key? Does it matter? If you have to choose, which one would you choose? A social security number or an email address as your primary key for the professor? What are your thoughts in terms of choosing a primary key if you have more than one option?
I will go with the social security number
But why?
because it's a number that you could increment to.
Well, not
So
quite, because
yeah,
each person will have a unique social security number, right? But maybe a preferred reason for having for having it as the key is assuming that everyone has a social security number, but not every professor will have an email address. Just assuming, right? So if some professors don't have an email address, because email address is optional, then in that case, the social security number is the preferred one, because some professors may or may not have an email address. So for that reason, the social security number would be the preferred choice of key. So whenever you have to choose, right, if you have more than one, choose one that is never null. Choose the one that will always have a value, that, you know, everyone will have a value for it, right? So that's the rationale with choosing a primary key when you have more than one alternate keys. Okay, so in terms of this here now, we would have discussed this example already. So we know that the entities are customer and the attributes of customer ID, the name, address, and date of birth. And for the contract was an entity and the price plan. We have discussed these already, right? Okay. So these are just repeating some of the stuff here. Next, we're going on now. So we've covered entity. We're going to an attributes. Let's look at relationships now. Relationship is what is the line that joins the two entities, right? So a relationship is simply the line that connects two entities, and that's called a relationship. Now, you don't just go and draw lines between any and any entity. There must be some kind of relationship between them in order to draw that line. So a relationship is simply an association between two or more entities. So for example, the relationship between a professor and a course is a professor teaches a course. So that is the relationship between professor and course. Or from the course side, a course is taught by one or more professors. So that's the relationship between course and professor. So a relationship can be described on both sides or either side if you wish, right? But what we're seeing is that there are relationships now between connecting entities. And once there's a relationship connecting entity, then you will draw your line between the two entities. So once there's a relationship, you would draw a line between the entity. So notice now there's a line between the entity with professor and course. Now in UML notation, you do not need to describe it in two sides. Because it's English, you can simply describe it in one direction. It doesn't matter if you choose this direction or the next direction. Now, the arrow here, the direction of the arrowhead tells you which direction teachers apply to. So the arrowhead says it's going this way, so it's going from professor to course. So then how you read this is professor teaches course. If you want the arrow to go this way, the next way, which is from course to professor, then the word here may change because it wouldn't be teachers, because course, teachers, professor makes no sense, but maybe course taught by. So you may use the word taught by and the arrow goes that way. So course is taught by a professor might be preferred. So in UML notation, you don't need to describe the entities in two directions. You only need to describe it in one direction on the diagram, because you could use English, general English, to be able to read it in the other direction. Okay, so note a relationship is only labeled in one direction, which normally means that the name of the relationship only makes, so this name only makes sense in one direction. So once a relationship name is chosen, an arrowhead symbol is placed next to the name, right, next to the relationship name, to indicate the direction for a reader to interpret it. So if you put the arrowhead this way, it means when you're reading it, it's read as professor teaches course. As I said, if you wanted the arrowhead to go the next way, which is from course to professor, so the arrowhead points professor, then you have to replace this with a word that's appropriate, such as course taught by professor. Okay. Now going back here now, when you are creating relationship, it's always important that you always start with a singular, meaning like you notice I have a professor, not many professors. Always start with singular, a or each or an. Never start with a plural. Or a course is taught by, right, etc. So always start with singular. Okay, so a professor can teach many courses. So later on, when we go to one to many, etc., it's important you be able to describe your relationship, because these words are what we will use in the diagram later on when we're using cardinality and participation to determine if it's one to many or many to many. Similarly, from the course side, a course is taught, in this case, a course is taught by one or more professors. So a course can be taught by one or more professors. Now, this here is based on the scenario given, right? These things here. Your scenario may be different. So professor and courses are both entities, and teachers is a relationship, okay? So the other thing is, if you cannot find a relationship between two entities, don't draw a line, because there's none that exists. Go ahead, someone who's going to ask a question. Anyone asking?
No.
Okay, just a note now. In terms of when you're talking about relationships, as I indicated, do not start your relationship with the word many. So, right? Okay, so don't say many students, because many will always lead to many. Many students enroll in many programs. Many programs will have many students. Never start with many, because the other side will always have many. Instead, always start with singular, like each or an, etc. So each student is enrolled on one program, and each program enrolls or has many students. Always start with singular. So in this case, the relation with students and program, from student side, there's one program, but from the program side, you have many students, right? So this is a one-to-many relation. But if I had started, instead of starting with each, and I use many, I'll have many students enroll in many programs, and therefore it looks like a many-to-many relation, which is wrong in this case. So in order to express the relationship between two entities, always use two sentences to express the relationship. Every relationship has two sides, so, and always start each sentence with the word each or an or a. Always use singular. If you cannot express the relationship between the entities and words, it means that there is no relationship, so don't force the issue. Now, in UML notation, when you're writing the names of relationship, right, this part here, it says use the capital, but this may not be accurate, so I'll have to remove this clause here. So we'll remove this clause regarding the naming of relationship, because I believe relationship can have a lowercase letter as well, okay? All right, next, all right. In terms of the degree of the relationship, right? So far, each of the relationship we looked at had only two entities, right? So they were called binary relation. A binary relation is simply a relation with just two entities. Now, ternary and stuff, other relations such as ternary, quaternary. Ternary is a relation with three entities, quaternary with four entities. They are not very popular, so you're not going to see much of them at all. So in terms of your case study, you wouldn't really see much of those either. So let's look at the examples of a couple binary, ternary, etc. Right? So take a look at this. This one is a binary relation. Just 1 second, please. So this binary relation is between professor and course, right? A professor teaches a course, and a course is taught by a professor. So a binary relation is simply a relation that only involves two entities, so that's why it's binary, okay? Next, a ternary relationship is really one which what we'll consider as complex. Once it's not binary and it consists of more than two entities, it's called a complex relationship, right? So in that case here, you may have a complex relationship with three entities, will be a ternary relation. So for example, if you have staff, a branch, and a client, right? It's possible that, you know, a client is registered, or staff registers a client at a branch, so you have a ternary relationship there. So this is an example of what we call a ternary relationship, where A staff registers a client at a branch. Okay, so that's an example of a ternary, but they are not very popular, right? And this is a quaternary relation, which in order for this relation to exist, all four entities must take part. But as I said, these are rare, so we won't bother to consider these because really the focus of the class is really to aid your understanding of your ER diagram. So I'll try not to teach ER in total, but ER more related in terms of your scenarios as well. Okay, so in terms of this here, let's see if we can identify the relation now with here. Now notice in each example, I'm using the same case study before and I'm building and building and building, right? So here we already looked at these here and we know that the entities are customer and these are the attributes, and another entity is book and these are the attributes. But is there a relationship between the customer and the books? Can you look at the description given here and can you tell if there's a relationship between the customer and the books as described here?
The customer buys the books.
Correct. So there is a relationship with customer and books. So if I'm describing from the customer side, the arrow goes to books, it will use buy as the relationship. Customer buys books. But if I'm going from the book to the customer side, what word would you use to describe the relationship? From the book to the customer, book.
Bought by.
Bought by, customer. Excellent, right? So from this way, customer buys book. But if I was going in the other way, it'll be book is bought by customer. Okay? But remember, again, in UML notation, you only need to describe it in one direction. So on the diagram, you only need to describe it in one direction. It doesn't matter which direction you choose. The word here has to be appropriate for the direction that you're choosing. All right? Okay. Next, we're going to look at a recursive relationship. A recursive relationship is one where an entity is in a relationship with itself. You will say, how is that possible? But for example, in your company, if you have, let's suppose you have an employee table. Well, let's use the example below, right? So a recursive relation is called a unary relation because it only involves one entity. So this is where an entity is in a relation with itself. So let's look at the scenario. You have a recursive relationship called supervisors, which represents the association of staff with a supervisor. So in this case here, you have the staff entity. So staff has a list of all the staff, right? So you have the staff entity, and the staff entity has all the staff who are employed. Now, for each staff, we need to store their name, their ID, etc. But we also need to store their manager. So each staff has one manager. But guess what? The manager of that staff is also the manager himself is a staff. So basically, the manager is not a separate table. The manager is also someone in the staff table. So therefore, if you have a staff table, the supervisor really is also in the staff table. So that is where you have a recursive relation with itself. So the staff table is the staff supervises another staff. Okay. Now I want to show you how they came up with this here. So in this diagram, this is the entity here, and this is the recursive relation, but I want to show you how they came up with it. So I'm going to switch from here, and I'm going to use now the whiteboard option. Now, in order to use the whiteboard option, I believe I have to stop sharing and then choose to share a whiteboard now. Good. So I'm using the whiteboard here, and I want to show you how they came up with that. So let's say you have the staff table. So this is the entity here. So this is the staff entity, and the staff entity now. So we want to track which staff manages which other staff. So this here is also the staff table. Now, in this case, what we have is a relationship with a staff, and this is manage. Right? So this is, the word here is manage or manages, and the arrow goes this way. So a staff manages another staff. Good. So this is an example of the supervisor's relationship, or supervise. Actually, if I were to remove this here and instead use supervise instead. So I'll use the word supervise instead. right? The staff supervise another staff, right? So if you have that, then in that case here now, arrow goes this way. So a staff supervises another staff. Now in an ER diagram, you cannot have the same entity more than once. So because you cannot have the same entity more than once, what we do as well is basically, if I take this now, so because I cannot have this entity listed more than once, if I take this line here and I move it from there and I bring it back to staff, and that is how you get it. So in the end, you have staff, and then it's linked to staff, of course. So this here's relationship, and this is supervisors, and it goes that way. So this is how they got the diagram. Of course, the arrow could go this way, or you could do it another way. This is staff. You could do it this way. You could do it here, going this way. Your choice, however you want to do it, right? But basically what you're trying to show is the relationship with itself. And that is how you show a recursive relationship. So again, I have to share with you guys also. I have to start back the share. Okay, so that's what you call a recursive relationship, where an entity is in a relationship with itself. Okay, now let's take a look at another example. Consider a scenario where a customer purchases a book for another customer as a gift. So a customer, before we had a customer buys a book, right? Remember that example before, a customer buys a book. What if now you want to track not just the customer who bought the book, but the person they're buying it for? You know, like if you call 1-800-FLOWERS, right? They will track who the caller is and who the person they buy it for as well, right? So they will track both the caller or the person who the gift is coming from and who it's going to. So suppose the bookstore also allowed for the tracking of a customer buying a book as a gift for another customer. In order to do so now, right, this here will involve the customer takes part twice in this relationship. So you have the customer buys a book, but when they buy a book now, they have to buy a book for another customer. So in such a case now, the customer takes part twice in this relationship. So the first one, this here is a customer buys a book, right? But what if the customer buys a book now for another customer? Then you need to add another link back to the customer. One as the purchaser and one as the receiver or the recipient. So this now becomes a ternary relation because you have this relation has three links, three connections, right? Customer taking part twice, one as the purchaser, one as the recipient. So, all right, so this is another example here of ternary. Next, an entity can also engage in one or more relationship with another entity. So normally you may be used to having only one link between one entity and another, but it's possible that you could have two entities having more than one relationship with each other. Let's take a look at this here. An employee can work in one or more departments. A department can have many employees. So this here, employee working in department, what are the two entities in that first sentence? Employee can work in one or more department. Could you identify the entities?
Employee and departments.
Very good. And in terms of the relation between them, the relation is work. So employee works in a department, right? Now, next, from the department side, a department can have many employees. Do you think that this is the same thing as above, meaning it's the same relationship, or is it a different relationship? These first two sentences, do you think these two sentences is really one relationship we're describing from each direction, or are they two separate relationships? An employee can work in one or more departments, and a department can have many employees. Is that the same thing we're describing in the different direction, one from the employee side, one from the department side, or do you see that as two separate relationships?
Separate.
So if I have a link between employee and the department from the employee side, describe it from the employee side. If I have employee and I have department and there's a link between them, from the employee side, you'll say employee works in the department, right?
Mhm.
And that same relationship now, describe it from the department side. What would you say?
And department has many employee, has an
Correct.
employee.
Right. So isn't that the same relationship, but you're describing it from the different sides?
Yeah.
So it's one relationship, but you use different words when you describe it from each side. And that's what these two sentences are. These two sentences is one relationship. From the employee side, you'll say the employee works in the department. But from the department side, that same relationship, if you describe it from the department side, the department have many employees, right? So these two here that I highlighted is really the same relationship, which
So
is,
that's two different relationships.
pardon?
There's not two different relationships because if an employee can work in one or more departments, that's a one to many, right?
Right. An employee can work in many departments. So the many is on the department side. It's not
Right.
necessarily a one to many. The many is on the department side.
Right. And then they say a department can have many employees.
Right.
So from the department side, they're saying for a department is the one and the employees is the many, which to
Okay.
me sounds like two different relationships.
All right. What you're looking at is the cardinality or the participation constraints, right? Which we'll do later, like the one and the manys, right? So we'll do one and many after. What we're looking at. So let's just go back a bit. Early on, when we were describing relation, right? When we describe a relation, we said in UML notation, in the diagram, you only need to describe it in one direction in the diagram, but really it exists in two ways. But you only need to describe it in one way because it is understood, because it makes the diagram a bit, when you add the description in both ways, it makes the diagram a bit more cluttered, etc. Because it's English, they assume that the level of the reader to do ER diagram, they should have a fair level of understanding of the English. So therefore, let's take a look at this here, right? From the customer side, how will you describe this? A customer
Buys a book.
Well, let's not focus on many and one as yet, but customer
Right.
can buy his book, right?
Right.
From the book side, what will you describe it in the other way? If you start from the book side.
Book is bought by a customer.
Right. Now, if I wrote those two sentences, a customer can buy one or more books and a book is bought by one or more customers. It's the same one relationship I'm describing, but I'm describing it in one way. I'm describing it from the customer side, where the customer is the subject, and in the other one, the book is the subject and the customer is the object. And so it all is the same relationship, but I'm describing it in two directions, right?
Right.
But it's one relationship, which is the buying of the book, right? And it's the same thing here now with working, right? The customer, what we're trying to show here, the relationship is between customer working in department, right? So from the employee side, sorry, not customer, but employee and department. An employee works in department, forget the one or more, right? But employee works in department, so that's the relationship is works in. And from the department side, the department has many employees or has employees. So it's the same one relationship, but the words we use, is slightly different from the department side versus from the employee side, but it's the same relationship that we're referring to. Okay. Are you following now? It's the same one relationship. Forget the one or many, etc. Because the one or more is simply when we do participation constraints, right? Okay. What you're focusing on is the relation between the employee and department. That relation can be described in two sides. From the employee side, it'll be employee working in the department. And from the department side, we'll say department has the many employees, right? But it's the same one relationship that we're talking about here. Now, let's look at this one here now. A department is managed by one employee. Is working in and managing the same thing? And an employee can manage many departments. So an employee can manage many departments. So let's look at here. Employee can work in one or more department. And this one is an employee can manage many departments, right? Think of it carefully and tell me if if these are two different sets of relationship.
Same. Please.
Yes, sir. Well, my first impression of it is a one-to-many relationship. Even though departments and employees are the common factors in the relationship, I would say the difference is how the second line is phrased compared to the first.
La Quinta, my apologies. Would you mind just repeating for me? My apologies. What you were saying?
I wasn't aware that you went.
Yeah, no, I was right here by the computer, but what happens is that I got a call coming in, so that's why I switched to the call, right? From so it's a student from class who was calling, so that's why. So I just basically pause it so that I could take the call. So I apologize for that. You mind just repeating what you were saying?
What I was saying is the first thing I'm seeing is the one-to-many relationship, and where department and employees is the common factors in both of the statements.
I'm not hearing you clearly though. It's very muffled. Sorry about that.
Are you hearing me?
I'm hearing you a bit better now.
Okay, so I'm saying that the relationship, right, actually, well, my impression is one relationship, but the difference would be that how the structure of the second sentence compared to the first, where to say that one department is managed by one employee, and then the other line would say that the employee is managed by many departments. So I'm thinking it's just a one-to-many relationship.
Right, but I don't want you to focus on one and many. What I'm trying to focus on is if there are two separate, distinct relationship between the employee and the department. So in each of these, the entities are employee and department. In all four of them, employee and department are the entities, right? Agreed?
Yeah.
Employee and department are the entities. So we have two entities, but this first two sentences here, what would the relationship be? The relationship in these first two sentences is the employee working in department, right? So the nature of this relationship here is employee working in department. But what is the nature of this relationship here? Is this about working in? What do you think is the nature of this relationship between the employee and department in these two sentences here? And anyone can answer. What you think is the nature, in these first two sentences, the nature of the relationship is working in, employee working in department. But what is the nature of this relationship here between employee and department?
Managing.
Managing. Now, working in and managing are two separate things. You could work in a department, but it doesn't mean you are managing the department, right? So working in and managing are two separate things. So what I'm trying to get here, if you look at the heading is saying an entity can engage in more than one relationship with another entity. So what I was showing here in this example, I wanted to show that you have two entities and there's more than one relationship between them. This first relationship is the working in, and this next relationship as defined by these two here is about managing, right? So we have two entities, employee and department, but there are two distinct relationships between them. One is working in and the other one is managing the department. So if I have to draw this on an ER diagram, I would have two different relationships. One relationship is for working in, and one relationship is managing. And now the thing is, I could put both going in one direction. It doesn't matter. So I don't want you to think, well, because this example has one in one direction, one in the other, means you have to do that way. If this arrow, this top arrow is employee works in department, this arrow has department managed by employee. If I change this arrow to go this direction now, from what would this word be replaced by? Instead of saying managed by, what would this word be? Employee what? Manages department, right? Good, but working in and managing are two separate relations. So the purpose of this example is to show you that with two entities, you can have more than one relationship between two entities. Not very common, but it is possible as well, right? Okay. All right. So this is another example of these as well, right? So the next thing we're going to look at now is I'm moving past these and I'm going now to, okay, I'll do this one here where relation in terms of the attributes, right? So the next one we're going to look at here is where relationships can have attributes, and this is more for this here is more popular in an ER diagram where you have a conceptual ER diagram. So let's look at a case now. Relationships cannot have primary keys, only entities can have primary keys, but there are situations where a relationship can have an attribute, but only in the conceptual ER diagram. In terms of that now, this is what we have here. Look at this example here. A university database contains information about professors and courses. For each course a professor teaches, we need to record his rate. That's his rate of pay per hour. Now, note the following. The rate of pay per hour varies from one course to another and from one professor to another. So before we know that there's a link between a professor and a course, right? A professor teaches a course. But if the rate of pay varies with the professor, so if that same professor is teaching 3 courses, what this is saying is that the rate of pay could vary from one course to another. So you could get 3 different rates. Similarly, if 2 different professors are teaching the same course, the rate could vary as well. So the rate is not fixed for the professor, nor is the rate fixed for the course. So the question is, where would the rate go? We can't put the rate on the professor because the professor doesn't have a fixed rate. We can't put the rate on the course because the course doesn't have a fixed rate either. So in this case here, the rate goes on the relationship because the rate varies with both the professor and the course, so it goes on the relationship. Okay? Now, just a thing to note as well, right? In terms of when you're reading, every attribute of an entity, it means, for example, the professor has a SSN and a name. It means that in order to have these attributes, it means a professor has only one social security number. A professor only has one name. If I had put rate in here, it means that professor gets only one rate, but we know that's not true. So that's why rate could not go here. In terms of the course table, the attributes, each attribute in an entity is saying that that entity will have one of it, meaning each course will have only one course ID. Each course will have only one course name. If I put the rate in the course table, it means that course, whoever is teaching it, will get that fixed rate. And that's not true either. So I cannot put the rate on the professor. I cannot put it on the course. And that's when it goes on the entity, on the relationship. And when it goes on the relationship, it's highlighted with dotted lines. And notice it's an attribute, but there's no, this is not an entity. So there's no name for the entity. It's just an attribute. Okay?
So you could go over that example again, because
sure.
That's a little different.
Definitely. Before I do, I just want to explain when you put an attribute in an entity, what it means. In the professor entity, in every entity, these attributes mean that each item only has one of it. So a professor has only one social security number. A professor has only one name. So when you have attributes here, it means that each person in this here has only one of it. So for example, if I had put telephone number in this table, it means a professor only has one telephone number. Okay? That is what it means once you have an attribute in an entity. Good? Similarly, in course, each course has one course ID, one course name. So any attribute you put in the table, it means each instance of it will have only one, like one course ID, one course name. So what does it mean if I had put rate in the professor table? It means that each professor would only have one rate, a fixed rate. So that professor gets a fixed rate of pay. So if a professor gets a fixed rate of pay, regardless of which course he teaches, the rate should come here because the professor will have a fixed one rate. If I had put the rate across here in the course table, it means no matter who is teaching the course has one course ID, one course name, and that is the rate for no matter who's teaching the course. So that's when you'd put the rate across here. In this particular scenario, a professor does not have a fixed rate of pay. His rate of pay varies from course to course. At the same time, a course does not have a fixed rate either because it depends on who's teaching the course. So let's suppose Maurice is teaching databases. He gets $100 per hour. But if Ravi is teaching database, I might get $50 an hour. So the rate of pay varies from one person to the other. So the rate is not fixed for the course, so I cannot put the rate in here. So if the rate cannot go in the professor and it cannot go in the course, it has to go in the relationship. In this, when they described earlier here in the previous slide, what they said here is that the rate per hour varies from one course to the other and from one professor to another. So it varies from professor and it varies with course. So it's not fixed for the professor, nor is it fixed for the course. So that's why the rate will go here. So let's look at these scenarios now. What if the rate was fixed for each course, meaning that no matter which professor teaches the course, the rate for that course will be the same. If this is the new scenario, where would rate go? Would it go on the professor or would it go on the course, or would it stay right here? If the rate is fixed for each course, what are your thoughts?
By the course.
Correct, because the rate is fixed for each course. So each course now has a fixed rate. So the rate will go on the course table. What if the rate is fixed for each professor? So no matter which course the professor teaches, his rate is fixed. Where will you put the rate in that case if the rate is fixed for each professor? So a professor gets one rate, no matter which course is teaching.
Under the professor.
It will go under the professor. Okay, so you follow this scenario now when you follow the scenario now when to put the rate, if it goes here versus here versus here. What I've also tried to identify here is whenever you put an attribute in a table, I also want you to understand what that attribute means. It means that for every professor, if it's a professor table, it means they only have one of it. Each professor will have one SSN, one name, one rate, etc. if you put it here. Okay? So we've just discussed those here as well, right? Now, let's take a look at this here. Each online customer, we did this part already, the first two, right? A customer is identified by customer ID as a name, address, credit card. A book has an ISBN and a title. A customer can buy many books. So early on, we did this scenario, the first 3 points, where a customer can buy many books. So we know that there's a link between customer and books, and that is called buys, right? Now, let's factor in this extra sentence here. It is necessary to record how many copies of each book a customer wants to buy. So whenever a customer buys a book, we need to record how many copies of the book the customer buy. So let's suppose you went and you buy copybook or textbook, like, you know, copybooks or notebooks, you buy 5 of it. Where do you track the number of copies the customer has bought? Would it be on the customer? Would it be on the book? Would it be on the relationship?
On the relationship.
Right? So we're saying here that the number of copies the customer buys should be on the relationship. What would it imply if we put the number of copies over here? So if I put the number of copies on the customer table, what would it suggest? It means that no matter which book a customer buys, they will always buy that number of copies.
Yes.
So it's saying that if I buy, let's say I buy a notebook for my son, if I buy 5 and I put copies 5 over here, it means if I buy another book now, let's suppose I buy his mathematics text, I have to buy 5 of it as well, because the number of copies is on the customer. So it means that customer has a fixed ID, it has a fixed name, a fixed address, a fixed credit card, and that customer has a fixed copy. So whenever you're buying a book, you have to buy that number of copies, right? That is what it means. What if I stored it on the book now? What would it have implied? If I put number of copies on the book here, that's the number of copies purchased. What would it imply?
And each customer have to buy that amount of books.
Correct. No matter which customer is buying, they have to buy that number of copies, which is not accurate either. So that is why number of copies is best placed on the relationship, because it varies based on both the customer and the book. And because the value of this varies both based on the customer and book, you put it on the relationship. Okay? Okay. Next. Now, I want you to add the following now. So we did the first 4 bullet points. So let's look at the one in red. Suppose now a customer may submit a review of any book. You know what it is to review a book, right? You know, you go and write a review for the book. A customer could submit a review on any book, and in which case you need to store the text of the review, right? Now, a customer doesn't need to review a book he bought, right? So you don't need to buy a book in order to review it, right? Okay, so you're not required for the customer to buy a book in order to review it. So I want to track review. The customer reviews a book. How would that be done?
You have to open an entity called review, and there should be a relation line from book or books to review.
All right. Now, eventually review will be an entity, but for starters, because we're dealing with the conceptual model, right? In the conceptual model, a customer could review a book, and when he reviews it, this is the text of the review here, right? Because the review will vary with a customer could review many books. So the review is based on the customer and the book, the review. So the review is an attribute of the relation. But later on, we will learn that because review itself can have a date of the review, time of the review text, and all of that. Review later on will become an entity. For now, review, all we're storing is they're just storing the text of the review. So I have it here as a relation, an attribute of the relation. But as we delve deeper later on, we'll show where review could be an actual entity. Good? All right. Okay. Now, what if we change the following? That when a customer buys a book, we need to add the review. So you can only review when you buy the book. So you could only review a book when you buy it. Where would review go then? Do we need a separate relation for this? The reason we separated it is because reviewing and buying are 2 different things. You don't need to buy to review. But now in this example, they're saying you have to buy a book in order to review it. So if you have to buy a book in order to review it, in this case, the review will go in this buy relationship here. Good. So the review now will be part of this, because reviewing, you have to buy in order to review. So that's why it goes there. Okay. All right. So what we're going to look at now is really, I'm skip a bit strong and weak entities, etc. And I'm going now to what we call is the constraints, the structural constraints. Okay. So this is where now we get to one to many and many to many, etc. Right. So in describing the one to many, etc. So we get now into multiplicity, right? So let me just move back a bit. So we're going to structural constraint, and structural constraint now is where we look at the multiplicity of the relation, like one and many's. Now in some books, they may describe the relation as simply one to one, or one to many, or many to one, or many to many, right? Okay, so these are different ways to describe the relation. It's called the relationship constraint, right? Or the cardinality of the relation. So those are different words to describe. So now we're focusing on the one and many's and that sort of thing. Now let's look at an example. This circle is one entity. This circle is another entity. These dots are the records in here, right? So these are dots. These dots represent records within the table. So this is one table. This is another table. And these dots represents the records in it. So this table has five record, this has 4 records, right? But anyway, if you look at the relationship here, right? This is what you call a one-to-one, meaning a record from here is only mapped to one on this side, and each record on this side is mapped to only one on the other side. So this is a one-to-one. So each record on this side, notice, is only mapped to one, at most one. It could have zero, but it means at most you have is one. And on this side, each record is mapped at most to one on this side. So that's why it's called a one-to-one. It's one from this side and it's one at this side. Now, if you take a look at this here now, this is called a one-to-many, right? Because notice here now, you can have here, it could be linked to many, right? One could be linked to many. So one record here could be linked to many. So notice this record here is linked to more than one record. This is what you call a one-to-many. This here is what we call a many-to-one. So many from this side, so you have linked to one on this side here. So on this side, this one here could have many records linking to it. So that's a many-to-one. And a many-to-many is where you have, for example, this is linked to more than one. So that's the many. And on this side, you have more than one linking to it. So you have a many on this side as well. So that's a many-to-many. So these are your tables, and these are the record linked, how they're linked. Okay, so those are the one-to-many, many-to-many, etc. So the number of possible occurrence of an entity that may relate to a single occurrence of an associated entity is the multiplicity constraint. So let's take a look. Now, in some instances, you will see on one side they may have just 1 and m, and sometimes in an ER diagram you may see like 1.1 or 1.3 or 1 star or 0.1, etc. What do these mean? If you see 1.1, it means the minimum is 1 and the maximum is 1. So it means that's 1 and only 1. Here the minimum is 1 and the maximum is 3. So it means where you're linked to between 1 to 3. So a record on one side is linked to between 1 to 3 records on the other side. 1 star means you're linked to a minimum of 1, but the star means could be many. There are no fixed amount. So this is 1 or more. So when you see 1 star, it's described as 1 or more, right? So this is the minimum and maximum, which is the participation constraint, right? 0.1 means you're linked to 0 or 1 record. 0.3 means you're linked to 0 but a max of 3. And 0 star means you're linked to 0 more records on the other side. So that's what these numbers represent. So what I'm saying now is that in some diagrams, you may see 1 or m, which is the simple way of doing it, but sometimes they may replace 1 with 1.1 or 0.1, and they may replace many with like 1.3 or 1 star or 0.3, etc. Notice when the maximum value is 1, this is your maximum value, it's called 1, and when the maximum value is more than 1, it's called many. So this is a 1, this is a many, this is a many, this is a 1, this is a many, this is a many. So all you do is look at the maximum value, and if it's 1, then you use 1 in the entity, and if it's more than 1, you use many. So this represents many. In order to better understand this, let's use diagrams to represent it. Notice here, right, you're seeing 0.1 or 1.1 here. This here, in a simpler case, could simply be represented by, so in some diagrams, you may just see this here as 1, and on this side, you may see this here as 1 as well, because the maximum value is 1. How do you read this here? This is saying, this is an example of a one-to-one. It's saying that a staff manages at 0 or 1 branch. So each staff, a staff may manage 0 branch, but if a staff manages a branch, they manage at most 1 branch. So that is what this is saying. So that's what this here is representing. So let me just go back to annotating. Right. So staff manages 0.1 is simply another way for saying this is a staff manages at most 1 branch. So 0 means that in some cases a staff may manage 0 branch, and in some cases a staff manages 1 branch. Of course, not every staff manages a branch. That's why you have 0 as the minimum. From the branch side, if every branch has a manager, then from the branch side, a branch is must have a manager. So branch is managed by 1, at most one and only one manager. So a branch has one and only one manager. That's from the branch side. So this is how you use these here. Whenever you're describing, the far value is, so it always goes, so the entity staff, relationship managers, and this value here, one branch. If I started with branch, it will be branch managed by one staff. Notice here, you don't use next to each other when you're going, if you're going in this from branch to staff, I'm ignoring this. If I'm going from staff to branch, I'm ignoring this. And I only focus on the far side. Let's look at some more examples as well.
So you can repeat how many numbers fall in relation to the in
Right. So when you're describing a relationship, right? When you're describing the relationship, so if I say a staff is managed by one, a staff manages at most one branch. So if the sentence is, so I'll just write the sentence here. A staff manages at most one branch. Where would you store this one? The rule is to store this one. So this, you're starting with staff, so you're starting with here, all right? And I'll do the other sentence, I'll put it at the bottom. So these are the two sentences that describe the relation, right? So I want to show you now how you move from those sentences now, how you move from these sentences to putting these here in the diagram. How do you know where this goes or where this goes, right? So let's start with the staff. So this is staff and this is branch on the side. So I'm going from staff to branch. I'm going from staff to branch, and a staff is managed by at most one, manages at most one branch. So staff manages, and this is where the one goes, it goes next to the branch. So it goes manages at most one branch. So because some staff don't manage any branch, it'll be 0.1. Good. So you could either use 0.1 or you could just use 1 if you prefer, but this is where it goes. So that will go on this side because we're going, when we go from staff to branch, this value here is next to, so staff is our starting point and the one is manages one branch. So the one goes on this side next to the branch. Let's look at this one here now. A branch is managed by one and only one staff. So I'm going from the branch. So we're starting with branch and I'm going over to staff. So therefore this value here, one and only one, should be next to staff because a branch is managed by one and only one staff. You're following now where you put these values always go on the opposite side. So staff manages one branch, so the one goes next to branch. If I'm starting with branch, I'm starting here, then this value has to go on the opposite side. So a branch is managed by one and only one staff, branch managed by one and only one staff. So it always goes on the other side. Of course, you could use one here instead of 1.1 if you wish. Good. So following from there now, let me just clear all the good. So next, let's take a look at this one now. All right. A member of staff can oversee 0 or more properties for rent. So this is another one we're looking at, right? A member of staff can oversee 0 or more properties for rent. So let's suppose now that I have staff. What are the two entities in this first line here? What are the two entities there? Can you suggest? What are the two entities from this first line?
Staff and properties.
Right. So the two entities are staff and properties for rent, right? Staff. And here's, I'll just call it staff and property, right? Good. So is there a relation between staff and property? It's described here, a staff oversees the property, right? So the relationship between these is that a staff oversees the property. So the name of this relationship here, what's the name of the relationship?
Oversee.
Oversees, right? So staff oversees the relationship and it goes in that direction, right? Good. Now, where do I put this here now? So the question to you is staff oversees 0 or more, 0 or more. Where would that 0 or more go? would it go in position A or would it go in position B? Where would it go?
B.
B, because you're starting with staff, so staff oversees 0 or more properties, so it goes in B, and I'm replacing B now. Instead of putting, what will B be replaced with?
0 to many.
or more. 0 more, I could either use many or I could use 0 ... star. So these are the two different ways to represent it. I either use just many or 0 ... star, which is 0 or more. Good? Good. And from the other side now, a property for rent is overseen by 0 or 1 member of staff. So what goes in, where would 0 or 1 go? By which letter? 0, 1, remember it's starting with property for rent. So the property is overseen by
A.
0, 1. So 0, 1 will go here. And how do you represent 0, 1? It could be represented either as 1, because 0, 1, the most it could be is 1, or you could use 0, ... 1, 0 to or 1, right? So you either use one or the other. Now you have to be consistent. If you're using 1, then you have to use, sorry about that. If you're using 1, then you have to use many here. If you're using this notation with the min and max, then you have to use min and max here as well. Okay? So you have to be consistent with it. All right? Any questions before I clear this drawing?
Nope.
All right. And this is our diagram here to illustrate as well, right? Okay. Let's look at this here now. One newspaper advertises 1 or more properties for rent. A newspaper advertises 1 or more properties for rent. And a property for rent could be advertised in 0 or more newspaper. So now, why you think you have 0 more newspaper? A property for rent is advertised in 0 more newspaper. What does the 0 imply? Why did they use 0?
You do have to do advertisement.
Exactly, because a property may never be advertised, right? So that's why 0 more. If it's not advertised, it'll be 0 more newspaper. So how many entities do we have so far here in this here? What are the entities? Newspaper and
Property for rent.
property. Newspaper and property, or property for rent, right? What is the relationship between them now? What would you put on each side? So if you were to draw it quickly, so let's say this is newspaper and this is property for rent. All right, so newspaper, property for rent. I'll just use, okay, newspaper. And this here is property here. And advertises is this here, right? Right, what will go, okay, what will go on this side here? So what will go on this side here, you think? You tell me the answer for here. Read the 2 sentences and tell me what goes here.
On that side is 1 to many, because I say 1 or more. No, 1 newspaper. Sorry. So it'll be 1.
Okay, now look carefully. Look at which side I'm putting it on. So if I'm
That
putting
should be
it
on the other side. You're saying the right thing, but it should be on the other side. That's what I was asking just now.
So I'm putting it here. So that's why I deliberately put it here, because in that case, the first sentence will not be applicable. You have to use the second sentence, because I'm going to newspaper. So I'm starting with property and I'm going to newspaper, right? So
Okay.
the second sentence, so it's basically a trick. I just really try to trick to see if
So
you will just
0 dot dot
zero more.
0 dot star.
So
Because it's
0,
1 0 to more.
right, excellent. And that is correct. So it'll be 0 dot, you follow why, right? Because this here is from property side. So property is advertises, a property is advertised in 0 more newspaper. And on this side here, what will it be? This is 1 or more, so it'll be 1 dot dot star. Okay? All right.
So some kind of borderline in this, right? When you say properties for rent, rent is not considered a relationship.
No, the properties are just properties that are rented as opposed to property for sale, property for whatever. They just call it
Yeah, but
properties.
why I think about it as a relationship is because I could say a person or a newspaper, a person rents a property is rented by a person, that kind of thing.
Right. Okay. So you will have, and that's where the lease comes in, right? So the we could just call it property or call it property for rent. It's the same difference because this company simply advertises properties, right? So the properties they advertise are really properties for rent. So that's why they call it properties for rent. I didn't give you the whole case study. I just extracted parts of it, right? So that's why. So the properties they have are properties that they're renting. So that's why they call properties for rent. But what I did, I'm only extracting the relation between the newspaper and the property as opposed to the person and the customer rents a property. That's a separate relation, but I didn't include it in the diagram here. Good. So you would have other rent or lease is the correct term that they use because you would have seen lease being used earlier on, right? Lease is the relation between the customer and the property. Customer leases the property. So that was done before for mounting. All right. So these are more or less ER diagrams. So this is how you illustrate the one to many, etc. And that was a question you guys would have asked already. Let's do this quick exercise here now. Let's see if you could do this exercise and we will close off here for it. See if you could identify this exercise or attempt this exercise. You may want to do it on paper if you wish, or we could do it together. Let's start with the first one. Each company has 4 departments and each department belongs to one company. So what are the entities in A? I'd like everyone to try it out. See if you can sketch it. If you have a piece of paper, whatever, it's just a quick sketch. Company and department. Right? What goes on each side? A company has 4 departments and a department belongs to one company. So company, let's say this is called has. Good. A company has 4. So what goes on the side here? What goes over here? Help me out. What goes here? Come on. Other than Maurice, sorry about that. Other than Maurice and Cecil and Kishore, we have some others in class. Anybody wants to take part in it to help out?
1 to 4.
Right. So over here we'll have 4. Very good. So a company has 4 departments, and from this side, a department belongs to. So department belongs to what goes on this side here?
One company.
One.
Company. So you recognize in terms now where they go, right? What the purpose of this is to understand where to put these values, right? Which side it goes. Next, a department employs many employees and each employee is employed by one department. So this, is there any new entity adding on to B? What should I add on to B to this? So this diagram, I'm building on the diagram. What should I add on if to include B now? What would I have to include?
Employees.
An entity called? Very
Employees.
good. Employees, excellent. Thank you very much. So this is called employee. We use singular, right? Employee. And the link is between what? Company and employee, department employee. What is the link in between?
Between department and employee.
Excellent. So I draw that link between department and employee, right? Okay. And you can describe it on either side. If I'm going from employee to department, belongs to, right? Right? Okay, so what goes on which side? So let's go on the department side. A department employs many employees. So where will the many go? Where will the many go?
Under employee.
Right, next to employee. So the many goes here. And from the employee side, each employee is employed by?
One department.
One
That
department.
one will go next to the department side, right? Good. Let's go to C now. Each employee has many dependents, and each dependent belongs to one employee. So is there a new entity I need to add for C?
Dependence.
Right. So I'm adding a new one called dependent, and that dependent is linked to the employee, right? And I have to add a line between them. Okay, and we give it a name. Employee has dependent. I don't know how to put it down. Anyway, you have an arrow going down, right? So I didn't bother to put it there. So good. All right, next. So so employee has many dependents. What goes next to dependents?
Are we just saying the arrow going down?
Remember, employee to department. Employee has dependents. So the has is described from employee to dependent.
And for department, should we have had the arrow going down as well from department to employee?
No, you could choose up or down for each one individually.
Okay.
So each one is its own relationship. So I'm describing it here. I'm describing belongs to is not from department. Belongs to is from the employee.
Okay.
Employee belongs to department, right? So that's why the arrow goes up, right? But here now I'm describing it from employee has dependent, but I don't know how to get the upside down V. Oh, sorry, that's just a V. Sorry. All right, so that's a V. So that's down. Sorry about that. Right?
Right. So many goes to dependents.
Right. Employee has many dependents. And
one employee will have.
Each dependent belong to
one employee.
Right? So you follow where to put the one and the M and etc. now?
Yeah.
Right? Yeah. Okay, so I don't need to complete this, right? Fitting. But given that's the case, I just wanted to show you how to normalize now a many to many. So now that you have these now, right? So you have the diagram, clear all drawings. Right. Okay, so this is your diagram developing it here into one, right? What I want to do now, I want to show you, after you've done your ER diagram, the next thing I want to show you is how to normalize the ER diagram. So in terms of normalizing now, so converting to convert your ER diagram from a conceptual to a logical, you need to remove any many-to-many relation. So if you have a many-to-many relation, it means your ER diagram is not a logical ER diagram. So the rule is to convert a conceptual to a logical ER diagram, you need to remove any many-to-many. This is the only one I will be doing, the many-to-many relation, right? So the rule is, if you have a many-to-many relation, how do you resolve a many-to-many? So the rule is that when there's a many-to-many relation, the original many-to-many will be replaced by two one-to-many relations. So you're replacing a many-to-many by two one-to-many relations. So for example, if there's a many-to-many relationship between entities A and B, so A and B has a many-to-many relation, then the steps to solve this is as follows. One, you add, sorry about that, guys. You add a link entity called AB in the middle of A and B. So you add that link entity in the middle of A and B. So that link entity goes in the middle of the two. So it breaks up the many-to-many, because the rule is a logical ER cannot have a many-to-many. And the only way to get rid of it is to add this new link entity in the middle of the two of them. So now A and B are no longer directly related to each other. Instead, A is linked to AB with the one next to A and the many next to AB. And B is linked to AB with the one next to B and the many next to AB, right? And AB, which is the entity in the middle, inherits the primary key from each of the two entities. Let's take a look. Let's suppose this is A and this is B, and this is a many, and this is a many-to-many relation, right? So for example, a property is advertised in 0 or more newspaper, and a newspaper advertises 1 or more properties. This is a many-to-many relation. You cannot have this in a logical ER diagram. So the rule is, what you're going to do is you add an entity in the middle, call it AB, and now A is no longer linked to B. Instead, A is linked to AB and B is linked to AB, and this is your new entity in the middle. And what you do now, this value here, so notice A on the opposite side of A is XY. On the opposite side of A is XY. XY now will go over here. So XY will go here and 1 will be here. So now we have a 1 and this is your many here, and you'll have a 1 here, and this PQ, this goes over here and your many goes here. So that is the rule. So notice as well, XY goes over here. So XY is opposite of A. So A has XY of B. So A now has XY of this. And the PQ now will go over here. All right. So if I apply this now, so notice now you have two one-to-many relations. So this is a one-to-many and a one-to-many. So when you split a many-to-many, you get two one-to-many relation. If I apply this to this here, if I apply it to this here, then this is what will happen. I'll have property for rent, I'll have newspaper, but I need to add a new entity in the middle, and let's call this advertisement. So this is your property for rent. I'll just abbreviate it P for R, property for rent, and this is my newspaper, right? So this is my newspaper. This now is what you call an advertisement, which is the relationship between the two entities, right? So this is called advertisement, which is the relationship between two of them. And what will happen here now is that property for rent now is linked to advertisement, and advertisement is also linked to newspaper. So now there's no longer many-to-many here. And what goes on the end? On the end here now, what you're putting here, 1 goes here, and 1 will also go over here. So the 1 goes here. And this value here is seeing 0 dot dot star here. The 0 dot dot star goes over here. And what goes over here? Can you tell me what goes over here on this side? What is on the opposite end of newspaper?
1 dot star.
So 1 dot dot star goes here. That's simply the rule. Good. All right. So that is how it works. So based on this here now, when you're normalizing, this is how it is done. So the 1 goes here, the 1 goes at the end, and the many goes here. Notice this entity here now, this entity in the middle, the many always inherit the foreign key. So the many side, the side where that has the many, always get the foreign key. So notice advertisement will get the primary key from the 1, which is newspaper name is the primary key here. It's stored in the many side. Similarly, here, this is a one-to-many. The many side gets the foreign key. So property for rent, which is the 1, is stored now in the many. So the rule now in terms of where do you get your 1 and where does your foreign key go? The foreign key always goes on the many side. The foreign key always goes on the many. So this is your many here, and this is your many here. So this inherits the foreign key. So I want to apply this now to some of the stuff you're doing. So I'm going to close this a bit now. And I want to just switch now to, I'm going to stop sharing. And I'm going to the whiteboard because I want to discuss something in your case study for you here now. All right, let me clear this whole whiteboard. Now, in terms of the whiteboard now, let's look at the user. And this is course. What is the relationship between a user and a course in your case study?
Enroll in a course, a user enrolls in a course.
Wonderful. So user enrolls in a course, right? Now, what goes here? So tell me what goes over here. A user enrolls in 1 or many. We just use simply 1 or M, right? A user enroll in 1 or many courses. Can enroll in only 1, or a user can enroll in many courses?
Many.
Many.
So many should go here because a user can enroll in many courses. From the course side, a course will have many students, right? So this, let's say this is a student, a course will have many students. What kind of relationship is this?
Many to many.
Right. Can you have a many to many in your logical ER? No. So what you do now, how do we solve this, guys? So this is users, this is course. What you have here now is your enrollment table. If you look in your ER, you will see that there's no direct link from user to course. Instead, you have the enrollment table. And therefore, the enrollment table goes here and is the same rule we just applied. So what will go on each end? What will go over here and what will go over here? We split the many to many and the ones will go on the end. And what comes in the middle?
Many.
The many. This is the exact thing we just did just now, but this is how you're applying it to your case study. If you look at the ER diagram we did when I did the IPR, right? The tutorial, the ER diagram, I removed all the many to many and I replaced them with one to many. So a user enrolls in a, normally a user can enroll in many courses and a course can have many users enroll. But now when you split it into two one-to-manys. And this is what you have to describe when you're talking about your normalization process. This is what you would have done in your normalization process. You would have converted your many-to-many into two one-to-many relation. Okay? Let's look at another example. I'm going to clear this here, right? And a course and unit. Now, depending on how you set it up, we said that, so this is unit here, right? A course could have, what goes here?
Many units.
Could have made up of many units. Now, we said depending on how you do it, depend on how you do it, a unit could belong to only one course, or depend on how you do it, you could use that same unit in another course. If you could use that unit in many courses, then many will go here, right? Okay, so if you could reuse units from one course in other courses, now why would you do that? Why could a unit be used in many courses? Because courses have overlapping content. I'm sure you would have done courses before where the content has overlap, haven't you?
Yes.
Yeah.
Right. So in that case, you could use reusable content where the content is used. So a unit could be used in many courses. This is a many to many. Let's solve this now. What goes on this end here? How many entities, how many boxes do I need to resolve this? Come on quickly, guys. How many entities?
Three.
Three. What goes on the left?
Course.
What goes on the right?
Unit.
Unit. And well, we could go, we'll have a need of course units if you want to call this course unit, right? So this is course unit and I have a link here. What goes over here in these two positions?
One.
What goes in the middle?
Many.
Is the same rule you're following over and over and over, right? That is how you think, right? So that is how you resolve these. Let's look at another case in your case study now. Sorry, I'm not taking over your time a bit, guys, but this is the only time we're doing the ER diagram, and therefore you need to understand your ER diagram to explain it and to be able to talk about normalization, because I've taught you the normalization now. This, what I'm teaching here is the normalization of your ER. At the end, I have given you a logical ER diagram, but the thing is the logical ER diagram is already rid of the many-to-manys. I already resolved it for you when I gave you the diagram. But the thing is, if you want to discuss your many-to-many, you need to understand. So I give you two examples where there were many-to-many that were resolved, right? And you have to describe this in your normalization process. Even for example, like exercise and question, right? So you can have an exercise and you have a series of questions here. In your database, you made up like this question table has a series of questions that you could reuse as many times as possible. So when you create an exercise will have many questions, but that question could be used in many exercises, right? Because this table with questions here, this table is simply a pool of questions you have, and these questions can be used in many different exercises. But an exercise will have many questions. So to solve this now, you'll have your exercise, you'll have your question, and you have your exercise question. So you call it exercise question here. Your one go to the end, and your many goes here. Good?
Yeah.
And this is how you do it. So this is your many-to-manys being resolved. So last thing now, I'm stopping share for this now, and I'm going back to your IPR lecture notes to look at the ER diagram. So in here now, when you look at your ER diagram, so if you look at this ER diagram, if you look, you're seeing this is users. Let me just go to my annotation again. Sorry about that. Annotation is not showing up. Let me get that annotation tool. Come on, where are you guys seeing the screen by chance? Oh, I didn't see the screen. Sorry, my apologies. That's why. Right. If you look at users, you're seeing users enroll in course, right? This is course over here. This is users here. This is, notice the link between users and course. It goes to here. It was a many-to-many initially, but now I've replaced it with enroll. And enroll now, you have the one on here, the many here. You have the one over here, the many here. This is the enrolled user enroll in course. This is what it turned out to be, right? So you could see how I applied it here. Users enroll in course. This is what it was. Look at the other one in terms of course and units. This is the course, right? And this is, well, in this case here, Marcus has course to unit is one to many, right? In his case, but if you had it as a many to many, you'll have to do that. Look at exercise and question. This is the exercise here. These are the questions here. It was a many to many. So you have the exercise questions created, and this is one, this is many here, one and many. I forgot to put one and M in this place here, right? Thing. Cool. So those are examples of where you have many to many that will resolve into one to many relations. Okay, guys?
Okay.
Yep.
All right, cool. And that brings us to the end of today's session. Any further question before we close off?
No, I'm good.
No, not yet.
Thanks for your participation as well. I really appreciated it also. And what I'll also do as well, I'll be sending out the 2 lectures, but remember I didn't cover everything in the lecture, right? I only covered some of them. And therefore you may have, you know, when you get the slide, it's a lot of slides to only focus on what is really required for your case study, rather than try to focus on everything. All right. And if you have questions, feel free to liaise with me regarding your questions. I'm more than happy to go over anything specific to your diagram. Okay. All right. Thank you so much. Have a good evening, everyone, and a good night, everyone. Sorry. Okay.
Okay. Bye.
Thanks.
Take care.
Good night, everybody.
Bye.